I've always played hockey my whole life, and so I'm still a fan. So it was interesting for me to set this up, but I think it'll give you some good insights into just thinking about your own data, how you might be able to aggregate data coming from your system and use that downstream. So let's take a look at the scenario. What we want to do is filter for tweets that are just specific to our use case. I just care about NHL related tweets. I want to know how many total tweets per hour contain hashtags for teams that are playing in that league, and I want to know the top 5 NHL related tags per hour. So basically, what teams are being most mentioned every hour over a period of time. And I want this data downstream. I want the filtered tweets saved to S3. I want the hourly aggregation count, so the total number of mentions across the board sent to Elasticsearch. And I want another output that contains the full team name, because the hashtag can obviously be fairly obscure. It might just be 3 letters. But I want the full team name that is represented by that hashtag. And I want to know the top 5 teams that were mentioned every hour, and I want to output that to Elasticsearch. So those are the requirements that we're going to walk through. So why is Kinesis Analytics a good solution for this problem? First of all, there's a few challenges that it helps to solve, but challenges when you're dealing with Twitter. One is if anybody in here has a Twitter account, and you probably have more data in Twitter than you actually care about, right? Depending on who you're following. So it's very noisy, right? There's a lot, you want to be able to easily filter out records that you just don't care about. The tweet structure is complex. If you've ever created a Twitter application that is reading from a Twitter streaming source, a tweet has got hundreds of attributes. And in most cases, most people care only about a couple of those attributes. And it's got several levels of nested JSON. And then the last one here, the NHL related tweet volume is cyclical. That's pretty obvious for any sporting event. Of course, the season is annual, but even within that, you will have most games are on weekends, so you've got busier periods during the weekend, and then of course in a period of a day, so on a Saturday, which is likely the most busy day, in the evening there might be all of the games, might be a couple of afternoon games. So you go from an annual cycle to a weekly cycle to a daily cycle. And so it's a very cyclical volume of tweets, and we're going to see that later in some of the outputs that we'll look at. So with Kinesis Analytics, why it's a good fit for this is it easily filters out the unwanted tweets, and we'll show how that happens. We can normalize the tweet schema for simple queries. It's a very complex structure, but Kinesis Analytics makes it very easy to convert that into a flat schema. And it automatically scales to meet the demand. So because of the cyclical nature of the tweets, I don't have to worry when I use Kinesis Analytics, well, I should probably add more capacity during the playoffs and reduce capacity during the summer. It automatically does that for me. So this is the architecture that we're going to discuss. If we look from left to right, we have Twitter on the far left. There's an EC2 instance here in the mix. I'll talk briefly about why that is. And then we have our streams. So Kinesis Streams is our input. Kinesis Analytics is the application that we're building, and then we're going to output data to Firehose and ultimately to Elasticsearch. So the use case we'll cover today will visualize some data that lands in Elasticsearch. So the reason we have the EC2 instance on the left, and this is just purely a remnant of the fact that we have to have something that pulls data out of Twitter. Twitter is not going to push data straight into Kinesis Streams. Twitter has an API that you have to call. Of course, Kinesis Streams doesn't give you the ability to call out, so you need an EC2 instance that sits here in the middle that is basically pulling the data from Twitter. Actually, Twitter is pushing it to you. It's a pretty cool API. They're just going to push tweet data to you in your application. But your application needs to do something with it. And in this case, it does a bit of cleanup, and it just relays the data into a Kinesis stream for buffering. So the EC2 instance here, it does do a little bit of cleanup before the data arrives in a Kinesis stream, because like I said, there's hundreds of attributes in the source, and we only need a few in our application. So it strips away some of those that we don't care about. Takes a tweet that might be 5K in total size and turns it down to about 250 bytes. And most of the attributes are just carved off because we don't need them. So this is a very common, actually, this is a very common use case if you're doing streaming Twitter analysis, is that you get rid of the data that you don't care about, and you put the stuff that you do care about into Kinesis, in this case, a Kinesis stream. There is lots of noise still coming from this, so when you create your own Twitter application, like on EC2, and you're reading data out of Twitter, you have to, you still can provide a filtering component to Twitter. So you say, hey Twitter, give me all the tweets that contain these hashtags or contain these keywords. And so this particular one that I'm running is getting all kinds of sports data. It's getting not just the NHL data, but it's also getting NBA, Major League Baseball, NFL. So it's getting a lot of tweets that aren't relevant for our use case, but are still useful perhaps in another application. But in my particular case, I'm just doing that so we have some noisy data, but it's relevant data, but we're going to trim it out, and we're going to get rid of it in Kinesis Analytics. So how are tweets mapped to a schema? So on the left is an example of a JSON document that represents a single tweet. And you can see at the bottom, there's a tags array, right? These are the hashtags that the person that tweeted this tweet associated with the tweet. So they put in the word NHL, they put in the word Canes. So Canes in this case is the hashtag for the Carolina Hurricanes. That will automatically get mapped when you create your Kinesis Analytics application to a schema. So the structure, we have an attribute of ID, text, created at, and then an array of tags. You can see on the right, which looks very much like a relational database table. We have an ID column, a text column, created at, and a tag column, but Kinesis Analytics will recognize in the array that there's a key value pair of tag and then the tag name, and it will create separate rows for me. So it makes it very easy to do aggregations. So now I've got two rows. Each hashtag is sitting in its own row. So that's now the input data to the rest of our Kinesis Analytics application. We now have this raw data containing a whole bunch of hashtags and a whole bunch of text coming through into a table in Kinesis Analytics. So before we get into the very specifics about this application, it's important to understand a couple of constructs in Kinesis Analytics. The first is called a stream, and what we have to be very clear about is that when I'm talking about a Kinesis Analytics stream, it's not at all related to the Kinesis stream that is the input. This is an in-application stream. It's a stream of data going through the Kinesis Analytics app, but it's not at all related to a Kinesis stream as input. So I will call a Kinesis stream in the rest of the session a Kinesis stream, and if I just refer to an analytics stream, we're talking about a stream of data going through the Kinesis Analytics app. It's unfortunate, it's a bit confusing, but it's important to recognize that they're different. A stream inside of Kinesis Analytics is analogous to a table, and it represents a continuous data flow. So in a relational database, you have tables, and the data is reasonably static. Of course, you can do updates and inserts, but in a relational database, it's fairly static, and it typically only grows unless you come in and you do a delete or you drop the table. So in streaming data in Kinesis Analytics, you have a stream which represents kind of a snapshot in time of data going through the system. And you can see this, the first command, the create or replace stream, NHL tweet stream, and then I'm defining the schema for my in-application stream. So it's got an ID, tweet text, and a hashtag. And then the next construct is called a pump. And that's important because now that I have a stream, which is basically a table, somewhere to put my data, I need to get data into it continuously. And a pump is like a continuous insert query. So it's running all the time, taking data that's coming from my input source, and it's inserting it into the stream so that I can now run more analytics on that stream to get my results. So those are two important constructs to understand, a stream and a pump. Think of a stream like a table, that's what you're going to use for your aggregation, and a pump like a continuous insert query that's always adding data to your table. So how do we model our data for this particular use case? These orange boxes, think of these as, these are streams. Think of them like a table. And just like you can do joins, inner joins, outer joins, things like that in static data, this construct of a stream inside of Kinesis Analytics gives you the ability to do the same thing, but on streaming data. So the orange boxes represent streams. The little green arrowy circles, think of those as pumps. So these are continuously running SQL statements that are populating data into your streams. So the first thing we wanted to do, right, was how do we filter unwanted tweets? So like I said, the input data, which is this source stream table, this is, if we go back a few slides, we would have seen where it converted JSON to a table. That's the table here. This is the source stream. We've got the ID, we've got the text, and we've got the tag. And then we want to filter out the data we don't care about. In this case, because I'm getting some data that's not relevant to my use case, you can see the select statement is extremely simple, where it just doesn't exclude. Give me all the records in my stream that don't contain NFL, MLB, and NBA. So now we've got just a NHL tweet stream inside my Kinesis Analytics application. So now every record that comes through has it's removed the records that I don't care about. So now we've got a stream, but all it contains is hashtags, and of course it contains the text of what the user said, and it contains the hashtags, but remember my output was the full team name. So that's where we can use reference data to do a join in our application to get some static data, because of course the static data is not going to change in this case. So what we've done is we've gone through and looked at all the official hashtags for all of the teams. We've created a file in S3. And so on the bottom, you'll see here CSV, where we have a hashtag and team mapping, where we have, you can see, for example, the first two are both for the New York Rangers. So we have NY Rangers and NYR, both of which represent the Rangers, and then the other three represent a few other teams. Because the output of our system needs to say New York Rangers, it shouldn't say NYR. So we want some way to use this mapping in our Kinesis Analytics application. And that's how we can use the reference data now in our queries. So when you create a reference table, like I did, the static data in S3, we have today it's only way to do it is through the command line, is you tell Kinesis Analytics, here's some static data that I want to import into my Kinesis Analytics application. Kinesis Analytics will bring that in as another table that you can use inside of your app. So in this case, it brought it in as a table called team name, and it created two columns, one called hashtag, one called team. And then my NHL tweet stream, which contains all of the streaming data that has just the hashtags, I now do an inner join on the two, and I just do a select and return the actual team. So now my output looks like that box on the right. It's just a new stream that contains only the team names. So it's converted the hashtags into team names, and that's another in-application stream. So now that stream is available to me inside of Kinesis Analytics to do something else. In this case, we're going to do some aggregations on it. So how do we aggregate streaming data? It's obviously a very common requirement. Most people who are doing analytics are doing some kind of aggregations. They're doing counts, averages, max, mins, right? These are very, very common. But you can't simply just aggregate over an entire stream, right? What if this stream was running for weeks or days or months or even a year? If you say select count star from stream, actually Kinesis Analytics won't let you do that. It'll break. It'll say, I need some context. I can't count every record that ever came through the stream because it's not keeping that around. So you need to give it some context. You need to say, tell me the count of these types of events in this period of time. In our case, we're looking to do it for an hour. And so how do you do that? And that's through windowing functions. So before we talk about a couple of windowing functions, it's important to understand the windowing concepts. There's two types. There's tumbling and sliding. They're fixed length, so you define it as a part of your query. And then the output, particularly for a tumbling window, will have a timestamp associated with the end of the window. So what does that mean? Let's compare the two types of windows. A tumbling window, it's a bit easier to understand. If I'm doing a tumbling window aggregation, and you say, I want to run an aggregation every 5 minutes, then at the end of every 5 minutes, you will get a result. It'll look at that 5-minute window, so let's just say between 1 p.m. and 1:05 p.m. It'll look at all of the events that occurred in that time frame, do the aggregation that you asked it to run, and it will give you a single result at the end of the 5 minutes. And then at 1:10, you'll get the same thing. So at 1:10 p.m., you'll get the aggregation that was between 1:05 and 1:10. If there were no records flowing through the system during that window, you'll still get a result. Your aggregation will just be 0 or whatever your aggregation is, right? There's no records to calculate There'll be a result, but there will be nothing to aggregate. With a sliding window, the window starts when the record arrives. So if I'm doing a 5-minute aggregation and a record arrives at 1:01 p.m., it'll go back in time in 5 minutes, look at all the records that arrived between 12:56 and 1:01 p.m. and do the aggregation. If another record arrives at 1:02 p.m., it goes back 5 minutes from that point, does an aggregation, and gives you a result. So you actually will have a result for every record that arrives, because that record is like the trigger that starts the window. So that's a sliding window. So if I want to know every time an event happens, what does that mean for a 1 hour period from the time that starts to the time that record arrives and back in time in 1 hour? That's a sliding window. If I just want results every 5 minutes, every hour, every 30 minutes, I don't care if there's records in there or not, that's a tumbling window. So today we're doing a tumbling window in our example, but it's important to understand the two types of windows that you can use with Kinesis Analytics. Cool, so now that we have that, we can look at how do we aggregate the team mentions per hour. So if you recall, we had that stream a couple of slides ago. So it's an in-application stream that just contains the stream names, right? It was the result of the inner join between the static data and the input data. So what we can use in this case is a function that we've created that we make available to you called top K items tumbling. It's a built-in function into Kinesis Analytics that's going to optimize the count of events in a tumbling window. It's pretty straightforward. We pass a cursor to a stream, an in-application stream, and in this case we're going to pass it a cursor to a stream that represents that streaming list of team data. And we're going to define a window size of 3,600 seconds, 1 hour, and we're going to tell it how many, the 5 here, the number of top teams that we want to count. So pretty straightforward. We have a number of built-in functions that we support. Top K is just one of a few. You can always do your own count, select count that you might typically do in SQL. But this is using some best practices. It makes it much simpler for you to do. We have a couple of other ones. One's called like random cut forest if you want to do anomaly detection. So the same thing, it simplifies a few very common patterns. And then another one is count distinct. We have a function that makes that much simpler as well than writing your own, and much more efficient than doing it all in pure SQL. So a couple of different functions that make it simple to do some very common use cases. And the final step is to output this somewhere. So because it's a tumbling window, we're going to get an output, in this case, every hour, right? We want to know the top 5 teams that were mentioned in a given hour. So we're going to have 5 records, 1 for every team. So this is an example of one record. In this case, New York Rangers, there were 604 mentions in the hour. And we're going to output that to Kinesis Firehose, which is going to do some amount of aggregation, and it's going to save it for us into Elasticsearch. So the JSON that you see here is just an example of one of 5 different rows that would be emitted at the end of that tumbling 1 hour window. And then we're going to write it into Elasticsearch so we can visualize it in Kibana. And the reason we've got Elasticsearch here in Kibana kind of all dotted together, if you're not familiar with Elasticsearch service, it's a managed service in AWS that essentially managed Elasticsearch. So if you're already familiar with Elasticsearch, if you're already running your own Elasticsearch environment, but you're doing it yourself on EC2, Elasticsearch service makes it much simpler. You just tell us how many nodes you want, where you want the storage to be, and it takes care of the orchestration of the Elasticsearch deployment. And it also includes Kibana. So that's why these are boxed together. So Kibana is already included in Elasticsearch. So if you want to run some visualizations in Elasticsearch, the URL for the Kibana endpoint in your Elasticsearch cluster is available to you in the console, and it's very, very easy. So what we're going to do next is, now that we've got all this data flowing into Elasticsearch, we have 1 hour aggregations of all of the team mentions. We're going to just it was very quick. We'll do a visualization in Kibana because it's already Elasticsearch. So it took about 2 seconds to go and get a view of like 1 day's worth of hourly aggregates for all the team mentions. And so you can see here, as I was talking about earlier, the cyclical nature, right? This is 1 day in the season. And I don't know, not sure how well it appears, but you can see there's one particular team that had a lot. I think it was the Chicago Blackhawks, had like a couple thousand mentions at that period of time. And was interesting but not surprising is this correlated directly with the schedule for the day, right? So you go look at the NHL league schedule, and the teams, of course, that were being mentioned here were the ones that were playing or about to play, and not surprisingly, the ones that were winning had a lot more mentions than the ones that were losing. So kind of a nice way to just visualize and compare the data. And so that's kind of an example. I know it's a sports-related example, but it does cover kind of an end-to-end flow and does a very simple aggregation. It covered a lot of the basic constructs that you need to do real-time analysis of streaming data. Hopefully it gave